Hey class, welcome back, and we are taking a look at the second part of Unit I, which is looking at some notes on the test of independence. So we worked through an example back here, which is taking a look at that gender and time of birth example and the steps that we went through, and then we did this one that was left for homework. Now there's some notes I want to go through here. Some pretty important stuff when you're doing tests of independence. So let's go through each one here. Number one says that randomness must be ensured in the collection of the sample data. That's just kind of like a motherhood statement that applies to any kind of sampling that we're doing, any kind of statistics that we're doing here, is to make sure that you've got a good sample design so you've got good randomness. Number two, the categories must be mutually exclusive. This is really an important one, and one that people will often make a mistake about. That is, an observation cannot fall in more than one cell. So for instance, a child cannot be born in both the 7 a.m. to less than 3 p.m. slot and at the same time be in the 3 p.m. to the less than 11 p.m. time slot. Well, you might look at that and say, well, that's obvious. Where it's not obvious is when you're dealing with problems that are check all that apply. Let me give you an example. I'm going to go back to, I think it's about page 41 here. So this is the library users questionnaire back in Unit D. And we were looking at why this is a bad questionnaire. I want you to take a look here at question number 3. And suppose that this was a check all that apply question. Check all that apply. And so again, now whether those are the only 4 options here, we'd have to talk with the library staff. But let's say those were just the only 4 that they were interested in. When you set up your spreadsheet, this is what the thing is going to look like. So remember, you've got rows and columns and so on. And so here are the different columns you've got. This would be question 3, and then the answer is book. Question 3, the answer is periodical. And then we've got question 3, the answer is get info from the librarian. And then question 3, answer is study. So these are 4 different columns then in your spreadsheet, and of course you've got a respondent for each row. And the way that you will code this then is that if they check it off, then you will put in a 1. So this particular person came in to search for a book and to get some information from the library. This person was only looking for a periodical. This person did all 3, that kind of thing here. It would be a mistake, it would not work, if you were to try to do a test of independence with all of these categories in one table. In other words, you couldn't do this kind of thing. Let's say we were comparing this to gender. You couldn't do something like this, males, females, and then have book, periodical, info, study, and then have the number of people in each one. And the reason is that a person can fall in more than one category. With check all that apply, they can check more than one category. So test of independence only works with a check one only kind of thing. So in our particular case then, you can do, say, gender versus something like, I don't know, a yes-no question. I guess, there's not great questions in this particular one. Were your needs satisfied? Are there any improvements? Yes, no. Of course, you'd want them to elaborate on that. So you could do male, female versus yes, no here because they're only checking a yes or a no. But you can't do with the check all that apply. By the way, how do you handle that kind of thing if you do want to compare this against gender? Well, what you could do is you could actually do a number of different test of independence problems. So you could do 4 separate ones. So you could take a look at book, and then this would be your little contingency table And so this would be males and females, and then you would have they checked book, or they didn't check book, like that. And so you could have the number of males that checked off book, and then the number that did not check off book, and then the same with females, and so like this. So that's one test, and then you would move on to periodicals and do a test of independence there, and then finally info, and then study. So you've got 4 separate tests there for that check all that apply. You may not be interested in all the categories testing it against gender, but that is the way that you would handle that. By the way, this is just an aside here, but when we're talking about gender, typically we would ask what your gender is and then put down as options male, female, and other. And if you have enough people here to use other, then you would include them in your analysis. But if you've got very small numbers, you actually won't be able to do that in a test of independence. And we'll see that going back to page I8 here in a moment. Okay, so let's just park that for a second. So let's go back here then to page I8. And so that is an important one that we looked at here. Number 3 here just simply says here to convert the expected frequencies into units comparable to the observed frequencies. So what we're getting at there is that if we go back to this example back here that I used, which is, of course, our birth and gender one, then what we have here as a total is 60. And so the total of the expected table must also be 60. Don't leave it like this. You don't want to do this where you're dealing with percentages or decimal values here. That doesn't work. They both have to add up to 60. So the sum of the Fij's and the sum of the Eij's must be the same. And you always convert the Eij's into comparable units to the Fij's. All right, so that's an important thing to note. Let's continue on down here. And we're taking a look at number 4. Now, this is where we're going to get back to what I was saying about parking the male, female, and other category here. This is a really, really important one. Actually, these are all important, but this one I'm going to put a couple of stars beside. Many books say that the sample size should be at least 50, and that none of the cells can have an expected frequency less than 5. However, studies show that the test is reasonably accurate for smaller samples as long as no cell has an Eij, not an Fij, but an Eij less than 1, and no more than 20% of the cells have Eij's less than 5. Now, the Fij's, they can actually be 0. That's not a problem, but you can't have an Eij less than 1 in any cell. And if you've got any that are less than 1, or if you have too many that are less than 5, then you need to combine columns or rows as necessary, or you might have to just take out a particular category. So going back to the gender thing, we would look at that and say, in that particular case, you've got male, female, and other. And let's say you end up, out of 100 people, you end up with 48 or 47 males, and then you've got 48 females, and then you've got 5 that choose other. The problem is that whole row of others, you're not going to be able to get high enough frequencies for the Eij's in that particular row. So what you have to do is to say, well, can I combine other with one of the other genders? Not really, not in this particular case. There's just as good a reason why you might want to put others with males as you would with females. So all we can do in that particular case then is to take them right out and just leave males and females. But it's important then when you write the thing up is to say that we also had 5 people who chose others, but that that wasn't enough for us to include in the test of independence. So let me explain this a little bit better actually in the next page. And the next page here says 400 Albertans were asked whether they agreed or disagreed with the following statement. If people had more education, there would be fewer people on welfare and unemployment. And then we classified Albertans according to the area of the province that they lived in, either Edmonton, Calgary, North, Central, or South. All right, so by the way, this was a real study that we did, and this was a real test that we did. And so this is what we ended up with down here. Now, this, of course, would have come from a pivot table, and the first thing that I would do when I get a problem like this is to take a look at the marginal numbers here. So I'm just going to add across here. So the first row adds up to 31, and then we've got 57. We've got 106 and 196, and that comes to 390. So that notice that the problem said 400 Albertans, but some didn't answer one or the other of these questions here. So it ended up with 390. We have 102 in Edmonton, 109 in Calgary, 70 in the North, 62, is that a 2 or a 7? I think it's 67. And then we've got 42 here. And 8, 9, yeah, it is a 7. Okay, so that's what we've got here. Now, oh, you know what? This is, we're actually going to put this one on hold here. We'll get back to it. Let's go down to this one here, and it says the same 400 Albertans were asked to respond to the following statement. If people had more education, there would be fewer social problems like crime and drug abuse. And so they were asked to answer that. So on this one here then, let's again put down the row totals. So it's 3 and 6 and 56 and 331, and then actually 396 people answered this one. So these numbers here are 102, 111, 72, 68, and 43. Now, the thing I want you to note here is, remember that the sum of the EIJs must be equal to the sum of the FIJs. And so when you think of this number 3 here, which is a row total, when we come up with the table of the EIJs, the expected frequencies, you realize that that 3 has to be spread across the 5 different categories. Well, you can't do that. You're not going to get enough values there. You're going to end up with EIJs less than 1, or if they are greater than 1, you're going to end up with all of them being less than 5. So you got a problem here. You got a problem with the 6 here too. So you can't really take 6 and spread that out so that you end up sizable enough EIJs. So what we do is we start to put things together. Now, what we can do here is to say, well, let's put the strongly disagree and the disagree together. That makes sense that we would do that. And so we would put these two together. The problem with that is that that still only comes to 9. And so you're talking about spreading 9 values out across 5 categories here. And it doesn't work. Your EIJs, remember, they have to sum up to 9 on that particular row, and they would all be they'd all be less than 5 in this particular case, because I mean, you've got Edmonton and Calgary are the 2 biggest there, and they're going to you wouldn't have either of them being greater than 5, and you're going to get some which are really small here. So you still got a problem there, as 9 is still not enough. So what do? Well, you could combine these guys together. And then what you've got here is 9 and 56 here then is 65. And what you would find is that 65, you would be able to actually come up with the sum of the EIJs across there that would have EIJs which are large enough. So in other words, what we would do is that this would become 12, and then this would become 12, and this would become 21, and this would become 8, and this would become 12. And so what you would end up with is actually a 2 by 2 matrix, where what we've got here, sorry, a 2 by 5 matrix, which is, you've got all of the different areas here, Edmonton, Calgary, North, Central, and South, and then you've got strongly agree versus what? Well, what is this here? The only thing we could say is it's not strongly agree. And that doesn't really make sense to put them together, because what we've got here is that most people are actually agreeing or strongly agreeing. You can't put agree, disagree, and strongly disagree into one category. That doesn't make any sense to do that. So what we do in this particular case, and when I was doing the study, this is what I had to say here, is because these totals are so strongly skewed, I mean, take a look at what we've got here, is we've got out of almost 400 people, you've got 331 of those 400. So that's about 85 or 80% or something like that agree. And then you've got a big chunk here that those are the ones that strongly agree. And then these are the ones that agree. And together, that's almost all of them. Together, what you've got here is 300 and, what would that be, 87 of the 396 people either agree or strongly agree. And then you've got very, very small numbers down here, about 1% and about 2% each that strongly disagree and agree. So you can't actually do a test of independence on this particular one, because when you try to collapse categories, it's just too skewed in terms of towards the strongly agreed side here. And you can't just put these three together and come up with something meaningful. All right? By the way, while we're here, it doesn't help in any way to collapse columns. So, I mean, you could look at this and say, well, we could put Edmonton and North together, and you could put Calgary and South together and Leeds Central. The problem is that these numbers are all quite healthy. They're big, and you can easily spread them out in terms of EIJs in a particular column. That's not where the problem lies. The problem lies in the low row totals. So we would have to actually combine rows, not columns. All right, let's go back here. And again, we're going to get to this guy in a moment here. But so it says here then, back number 4, always take a look then at your EIJs and do a count. Count and see, are there any which are less than 1, in which case you've got to either collapse that row or column into another row or column, into another category, or if it doesn't make sense to put them together, you have to actually just take it out. Okay? And the same with if you've got them less than 5. So you count up the number of cells where the EIJs are less than 5, and you're allowed up to 1/5 of the cells. So 20% of the cells can have EIJs less than 5. But otherwise, you should be collapsing them or combining categories. All right, number 5 says it is never sufficient to conclude that there is a relationship and leave it there. If a relationship is shown to occur, then the relationship must be described. So, for example, men tend not to wear nylons, women do, when we looked at that example earlier. A simple way of determining the relationship is to circle or underline all the Fij's that are larger than their corresponding Eij's. And what you'll see is that a pattern will emerge, or will likely emerge, and then you can describe the relationship there. Okay. It is possible, so down here it says, it is possible that no clear pattern will occur in the Fij's. And in that particular case, then, it's probably just a type 1 error that occurred. So you ended up rejecting HO when, in fact, there really isn't any relationship. And if there's a relationship, you should see it in a pattern that tends to occur there. Let me show you in this example here. So I already gave you the marginal totals and so on like this, but let's take a look at the ones that are underlined. So the ones that are underlined are the ones where the Fij's turn out to be larger than the Eij's. Right there. And the question is then, how would you describe this relationship? So what you can do is you can pause the video at this point and just look at this and see, is there some sort of pattern there that you tend to note? All right. Okay, I'm going to assume that you've done that. And the first thing that I want you to note is, if you take a look then at these marginal values here, you'll see that really most people, almost half of the people here, strongly agree. And then another quarter agree. So it's important to state that. We'll actually see that in point number 5 above here. Okay, so it's important to state that. But then what do we notice here? Well, probably what we notice here is that the big cities feel more strongly about it than do the rural areas or the smaller cities. Okay, so what we would say here then is that there's a strong tendency towards agreeing or strongly agreeing. Strongly, it's a funny looking S, agreeing with the statement for all regions. You can see that with every column here. You can take a look at the numbers. The numbers get bigger as you go further on down the column here, right? But the larger cities feel more strongly either agreeing or disagreeing in the rural areas than we would expect. So remember, the circled numbers here are the ones where the Fij's were higher than the Eij's. And so what we find here then is that there is, with the big cities there, it's the strongly disagree and the strongly agree here that tend to be higher, whereas they tend to be more bunched in the middle with the agree and the disagree in terms of the north, central, and south here. But overall, we see that in all regions, there's a strong message that they agree or strongly agree with it. By the way, just as an aside here, I'm not going to work through the test of independence for this one, but it says that the chi-square star value turns out to be 21.69. And so you could go and try this out here. Let's, just as an aside here, take a look at what would the critical value be. Well, the critical value, remember, would be a chi-square upper tail test. So here, let's just draw a little chi-square distribution up here. So here's a chi-square. And how many degrees of freedom would there be? Well, you've got 1, 2, 3, 4 minus 1 rows, and 1, 2, 3, 4, 5 minus 1 columns. So 4 minus 1 is 3, 5 minus 1 is 4, so that's going to be 3 times 4 is 12. And then this is always an upper tail test. So here's your alpha of 5%, and let's just go and find that value there. So here's 12 degrees of freedom, and we're going to go across here until we find the 5% column. And so there's your critical value. It's 21. And what page was that on again? 68, a little further on here. Okay. So it's 21. And so when we get 21.69, it's just over that into the critical region. So what you would find is if we calculated the p-value to be pretty close to 5%, and be just under that 4-point-something%. So that's something that you could try if you wanted. But the important thing here then is to show how you would read the relationship here. So let's go back here then. And we've just taken a look at number 5. It's never sufficient just to conclude that there's a relationship. What you want to do is to describe it. So you look for a pattern, and we just described it. And then the last thing down here, which we've really covered, but regardless of whether or not there's a relationship shown to occur here, the problem should always start by examining the marginal totals. So in this particular case then, we've already talked about this, and we've said here that when it comes to this particular question here, we've got just about 50% of the people here strongly agree with this, and another quarter agree with it. So you've got over about 75% of the people who either agree or strongly agree with this. And then the other 25% or so is split between strongly disagree and disagree, and you could give the percentages for that. We'd also describe these numbers down here. So we took a sample, and out of the 390, 102 were from Edmonton, which is about 33% or no, closer to 25%, 20-something%, and then another 27% or whatever from Calgary. I'm not sure what the numbers are, and so on like that. So we describe both of the variables separately in terms of their marginal totals expressed as percentages, and then you can go in and describe the relationship. Over here, of course, you can see that it's even more important to describe these down here. So we've got almost everybody is strongly agreeing with this. There's a sizable number of people that still agree, but together they make up about 97% of the people. So people are really agreeing with this statement, and there's only about 1% here and 2% here that actually disagree with it. So only 3% in total that either strongly disagree or disagree, and we'd want to state that here. All right, so we come back here, and I think we've covered what we need to on this here. Categories mutually exclusive. Always make sure that your EIJs sum up to your FIJs. Check to see that you don't have too many small EIJs. And then when you come to describing the problem here, start with the marginal totals and then describe a relationship here if one exists. All right, if one does not exist, then you just simply state that. So those are some important things going forward here. The last part here, actually There's a little bit of Excel after this, but let's just talk about this thing called the test for homogeneity. And it sounds like a completely different test, but the important thing here is that it's basically the same animal as a test of independence. And we'll quickly work through this particular guy as well. So what this is about here is that in the test of independence, a sample is selected from a single population and classified according to two variables. In the test for homogeneity, a separate sample is drawn from two populations, and the number in each sample falling into each category of interest is determined. The thing to note about here is, from a conceptual point of view, there is a difference, but from an actual calculation point of view, there isn't. So in other words, we can think then of method 1 and method 2 as being two different populations here. And then we find out, is the rating fair or unfair in each case here? But really, in terms of practicality, that's no different than thinking of it as being one big population, and you're measuring two different things. One is the method that is used, and then the rating. Is it considered to be fair or unfair? So the only difference would be in the way that the wording in HO and HA is done, but otherwise it's exactly the same problem. It's a test of independence kind of problem here. So HO and HA here is that there's no difference between the populations, and HA is that there is a difference between the populations. That would be equivalent to saying that the two are independent. So the methods in this case are independent from the ratings. And so let's go and actually do that one. And actually, I'm not going to do that one. I'm going to leave that one for homework here. So we've got another couple of problems to work through here. So I want you to do that one. Set up the HO, the HA, work through this just like it was a test of independence. Okay. And the last part of this unit here is just to show you these notes here. I actually made these notes before I did any videos, and so it's a bit redundant, but you've got it in paper as well, so it shows you how to do this step by step in Excel. So you've got your pivot table that creates your observed frequencies using a pivot table. So those are your Fij's, right? And then you're going to create your Eij's, and so this is how you do the thing. It's the row total. So going back up here, it'll be the row total times the column total divided by the grand total, and that'll give you, for this particular cell down here, the Eij. So this is the Fij, I guess the F11, and this is the E11, right? So that's how you do that. The dollar signs, the way that you think of this in terms of the dollar signs is that in a column here we've got, you're always going back to column D to get the row totals, and you're always going to row, I guess I'm using this one down here. Okay, so these totals here are just copied down from above here. So you're always going to column D, and you're always going to row number 11 here. And so what we do over here is we fix all the 11s and all of the D's with dollar signs in front of them. If it's not an 11 or not a D, you don't do that. Here we've got both a D and an 11, so you can always take a look at your grand total, and that tells you what to fix with the dollar sign. And so all of the D's and all of the 11s have dollar signs in front of them. And if they're not D's or not 11s, you don't put a dollar sign in front of them. You do that for your first cell, copy it across, copy it down, and you get your Eij's. And then what you do is you use a really simple formula that looks like this. It's called the chi-square test function. And it's just chi-square test. And then B3 to C4 are these guys here. It's the actual Fij's without the row and column totals. And then The second argument are the EIJs, the corresponding EIJs, right there. So those are the two arguments that you have here. And the answer that it gives you is a p-value. It's that easy, which you compare to alpha. And if the p-value is less than alpha, you reject HO. Okay? If you calculated your chi-square star, this is how you would get the critical value. I'm not going to worry too much about that. This is the one that I want you to use. It's a really simple thing to do. And this unit ends with some additional problems to do by hand on page I14 and I15. And then the solutions are shown on the next couple of pages. And that takes us to the end of the unit. So that is it. Thank you for watching. I'm going to end the video here.